Okay, question 9. Okay, question 9. Show the volume of the cylinder equals to the pi r times 12 minus radius, and find the radius when the volume here maximum. And question C, find the maximum volume of the cylinder. Yeah. Okay, first given the total surface of the cylinder equals to the 24 pi centimeter square, and you draw the cylinder here. Okay, so you draw the cylinder and two circles, pi r square plus pi r square here equals 2 pi r square. Okay, and combine with the 2 pi r times height. Yeah, so this total cylinder equals to the 24 pi, and you show the volume of the cylinder here equals to the phi r times 12 minus r square. Okay, so this volume of the cylinder in terms of the height, in terms of the radius. Okay, so this volume of the cylinder in terms of the radius. So the method here, you write down the height of the cylinder in terms of the radius. This one is the method to solve this question. Okay, so the volumes of this cylinder contains only the radius, pi r times 12 minus r square, and no terms heights in this volume. Yeah. Okay, first method, write down the height of the cylinder here in terms of the radius. So you write down the equation 2 pi r square plus 2 pi r times h equals to the 24 pi. This one the total surface of the cylinder. Okay, so move out the constant. So constant here equals to the 2 pi, and move out the radius. 2 pi r, 2 pi times the radius times r plus h, and equals to the 24 pi. And here 24 pi over 24 pi, 2 pi times the radius. And this one you cancel and write down the h here in terms of the radius. Okay, h in terms of radius, h equals to the 24 pi over 2 pi r minus radius. So this one pi over pi here equals to 1. And 24 over 2 here equals to the 12. Yeah, so 12 over radius minus radius, and the denominator of this terms in terms of the radius, so you cross multiply. Yeah, so the radius times the radius, 12 minus r square, and denominator here equals to the r. Yeah. So hash here equals to the 12 minus r square over r. Okay, and given the volume of the cylinder, pi r square time hash. Okay, and the hash here in terms of the radius, hash equals to the 12 minus r square over r, and you substitute this height into the volume of the cylinder. You substitute here. Okay, so pi r square time hash. This one pi r square times 12 minus radius over radius. Yeah, and then answer here. This one you cancel. Okay, and then answer volume of the cylinder equals to the pi r times 12 minus r square. Okay, question A. Okay, question B. Find the radius of the cylinder when the volume here maximum. Yeah, so maximum when the first derivative using the first derivative test or using the second derivative test. Okay, first the volume of the cylinder, phi r times 12 minus r square. And volume here equals to the 12 pi r minus pi r cube. Yeah, you write down the volume here in terms of the radius, and then find the first derivative, dv over dr equals to the 12 pi minus 3 pi r square. Okay, and you let the first derivative here equal to 0. 12 pi minus 3 pi r square equal to 0, and find the value of the radius. So radius here, r square equals to 4, and r here equals to the plus minus 2. Yeah, so you reject the negatives value, and the radius of the cylinder, radius here equals to the 2. Yeah. Okay, and using the first derivative test determines the relative extremum point. Okay, so first row here you put the radius of the cylinder, second row the first derivative dv over dr, and the third row here shape of tangent. Yeah, the radius of the cylinder here, radius equals 2 centimeter. So from the left here the nearest value equals to 1, and here the nearest value equals to 3, and you substitute this radius into the first derivative dv over dr. And here sign when x radius here equals to the 1, sign here positive, and 2 here equal to 0, and when radius here equals 3, the first derivative here equals to the negative sign. Yeah, so the shape of tangent increase, here the horizontal line, and here decrease. So the relatives maximum here exists when the radius equals the 2 centimeter. Yeah. Okay, or you can use the second method using the second derivative test. So second derivative test, you find the first derivative 12 pi minus 3 pi r square. And then here you find the second derivative, negative 6 pi times the radius here. So the radius here equals to the 2 centimeter. So you substitute into the second derivative, and answer here equals to the negative 12 pi. Yeah. So sign of the second derivative here negative, and the conclusion the relatives maximum point. Yeah. So the volume here maximum when the radius equals the 2 centimeter. Okay, and the next question, find the maximum volume of the cylinder. So the volume of the cylinder equals to the 12 pi pi r times 2 minus r square, and you substitute the radius here into the volumes. Radius equals to the 2 centimeter. You substitute here. Okay, so pi times 2 times 12 minus 4. So the volume here equals to the 16 pi centimeter cube. Okay, so you check the question. The question here show the volumes B here equals to the pi r times 12 minus radius. If I change this question, this volume change to the in terms of height. Okay, so if this question volume here in terms of height, pi h times 12 minus h square. So the method here, you write down the radius here in terms of the height. Yeah. So the proven volumes contain only the heights and no terms radius.